Good evening, friends. Welcome to fifth lecture of control system. Before going to start today control system, let me once again explain about myself for newcomers. Myself Vishnu, teaching control system and power system across the country since 10 years. Trained under me more than 50,000 students settled at various places. Okay. Anyhow, let's continue the basics of transfer function. Last class we discussed transfer function calculations with respect to mathematics as well as signals and systems. But I have explained the basics of signals and systems. Today I will continue how to solve the questions related to transfer function with respect to signals and systems. Okay. But before going to solve the questions in signals and systems, that is to determine transfer function, already we discussed four signals yesterday. The first signal is called impulse signal. The impulse signal is also called as natural signal. Therefore, always transfer function can be related to natural form because the transfer function is relating input and output of the system naturally. Therefore, the transfer function of a system always must be related to impulse signal. We know transfer function is defined as ratio of Laplace of output to the Laplace of input by assuming initial conditions are 0. Dear friends, whenever output of the system is given, input of the system is given, how to calculate transfer function? This is the simplest formula that you have to remember while solving questions. Suppose if input to the system, that is R of t represented by del of t, that is impulse signal is given, then output of the system is represented by C of t, then what is transfer function? By assuming initial conditions are 0, the transfer function is defined as ratio of Laplace of output, it is output to the Laplace of input. Well, already we given that formula, where output is represented as C of t, input is given as impulse input, that is del of t. Laplace of del of t value is 1, therefore the transfer function right now is simply Laplace of output, that is C of t. Because this value Laplace of del of t is 1, yesterday we have discussed in basics class. Whenever input is impulsive or impulse input, then output of the system also impulse output, or we can call it as impulse response or natural response. Why? Because impulse input is also called as natural input. Therefore, the name of the output we given here as impulse response. Therefore, I can write transfer function is also Laplace of impulse response. This is the second formula that you have to remember. Once again, I am repeating, dear friends. Whenever output and input directly given, how to determine transfer function? Use this formula. Whenever impulse response is given, how to determine transfer function? Use second formula. Suppose, dear friends, we know transfer function and they are asking to calculate impulse response, then impulse response or natural response, L is coming this side, it will be inverse Laplace of transfer function. This is the third formula. Whenever transfer function is given, if somebody is asked you to calculate impulse response, use this formula. Okay. Now, transfer function definition is Laplace of output to the Laplace of input by assuming initial conditions are 0. This is the one formula that already we discussed in previous slide. Now, another formula is transfer function is Laplace of impulse response whenever impulse input is given to the system. This is the second formula. If they given impulse response, how to determine transfer function. Now, dear friends, in place of transfer function, I am replacing this value. That is, Laplace of impulse response is equal to Laplace of output upon Laplace of input. In some of the questions, while calculating transfer function signals and systems, they will give in these three any two terms, then they are asking third term. Right? At the time, we can use directly this fourth formula. This is the formula number 4. Suppose, dear friends, if they given response of the system, which means output, and they given impulse response of the system, and what is the input, at the time use this formula. Or else, if they given impulse response and input, how to determine output of the system, also use this formula. Okay. Now, entire signals and systems questions while calculating transfer function, it depends only on four formulas. The first formula is transfer function is Laplace of output to the Laplace of input by assuming initial conditions are 0. Formula number 2 is Laplace of impulse response to calculate transfer function if they given impulse response. Suppose if they ask if they ask impulse response from the given transfer function, then impulse response is Laplace inverse or inverse Laplace of transfer function. The fourth formula is Laplace of impulse response is equal to Laplace of output to the Laplace of input. Only these four formulas you have to remember. You can solve any questions in signals and systems while calculating transfer function of the system. Okay. I hope everybody understand all the basics. Now we are going to start some of the questions how to solve transfer function with respect to signals and systems. The first question, impulse response of a system is given as e power minus t minus e power minus 2t into u of t, then transfer function of a system is. Now they given only impulse response. There is no output, there is no input. I given very simple formula, that is transfer function is equal to Laplace of impulse response. Laplace of e power minus t minus e power minus 2t. Laplace of e power minus t 1 upon s plus 1 minus Laplace of e power minus 2t 1 upon s plus 2. Simplifying, s plus 2 minus s minus 1 upon s plus 1 into s plus 2. Now solution is 2 minus 1, which is 1. 1 upon s plus 1 into s plus 2. This is the solution for this question. Okay. Now dear friends, second question or dusra question, impulse response of the given system is, this is the system. This is input to the system. One block gain is given 1 by s plus 1. Another block gain is given as 1 by s. And this is output. And the ratio of output to the input, Laplace of output to the Laplace of input by assuming initial conditions are 0 is nothing but transfer function. Now transfer function is just these two blocks are cascade. What is the result? Multiplication. 1 upon s into s plus 1. Right now, indirectly in this question or from this block diagram, we know the transfer function. And what is the question is asking? What is the impulse response of this given block diagram? Right now, no output, no input, directly transfer function is known. How to calculate impulse response or natural response, dear friends? Inverse Laplace of transfer function. Simple formulas. Now, inverse Laplace of 1 upon s into s plus 1. There is no direct formula. This can be written as a by s plus b by s plus 1. Partial fractions. From this, 1 is equal to a into s plus 1 plus b into s. Put s is equal to minus 1. Minus 1 plus 1 will be 0. That is minus b equal to 1, which is b equal to minus 1. Put s is equal to 0. Here 0 plus 1, 1. That is a equal to 1. Now, impulse response or natural response is L inverse A by S. A value is 1 by S. B value is minus 1. That is minus 1 by S plus 1. Now impulse response is L inverse 1 by S is 1. L inverse 1 by S plus 1 is e power minus t. And inbuilt function is u of t. This is the impulse response of the given system. I hope this question also simple. We got the solution. Another question. Impulse response of linear relaxed system is given as e power minus 2t into u of t. This is the impulse response of linear relaxed system. To produce a response means output. Another name of output is response. To produce a response of t into e power minus 2t into u of t, the input must be equal to impulse response of linear system is given as e power minus t u of t, and to produce a response or output of this much t into e power minus 2t u of t, then what is the value of input is asking. Okay, now input, output and impulse is given, therefore we have to use this formula, that is Laplace of impulse response is equal to Laplace of output upon Laplace of input. From this, what is unknown? Laplace of input. Therefore, I can rearrange the equation like this. Laplace of input is equal to Laplace of output upon Laplace of impulse response. Now, output is, our response is given t into e power minus 2t u of t, and impulse is given e power minus 2t. Now, dear friends, Laplace of t power n e power minus at form. Therefore, the formula is n factorial, which is 1 upon s plus 2 whole square upon 1 by s plus 2. Now square and 1 by s plus 2 cancelling. From this, Laplace of input is 1 upon s plus 2. But question is very important, friends. According to Albert Einstein, if you understand the question properly, 50% solution is completed in any kind of exam. Please remember this quotation while solving GATE question paper or ESC question paper or any state government or central government or PSU's papers. The question is very clear. He asked input of the system, but he did not ask Laplace of input. Right now we have calculated Laplace of input. From this, how to calculate input, dear friends? Inverse Laplace of 1 by s plus 2, which is equal to e power minus 2t into u of t. This is the way we can solve the questions in case of signals and systems. Now, once again, we'll move to another question. Another question is impulse response of impulse response of initially linear relaxed control system is given as 2 into e power minus 2t into u of t. To produce a response, once again same kind of question. To produce a response, that is output of 1 minus e power minus 2t into u of t, then input must be equal to, same question, just data is changed. Once again same formula, Laplace of input is equal to Laplace of output upon Laplace of impulse response. Now Laplace of output is given, or response given, 1 minus e power minus 2t upon impulse is given 2 into e power minus 2t. Dear friends, we know that Laplace of 1 is 1 by s, e power minus 2t is 1 by s plus 2. Laplace of 2 e power minus 2t is 2 upon s plus 2. The simplification will be s plus 2 minus s upon s into s plus 2 upon 2 upon s plus 2. S plus 2 cancel. Now s cancelling and 2 also cancelling, which is equal to 1 by s. Question is input of the system but not Laplace of input. We calculated as Laplace of input. From this, input is inverse Laplace of transfer function, 1 by s. The input is inverse Laplace of 1 by s is 1 into u of t. This much of input is required to produce a response of 1 minus e power minus 2t u of t for the initial linear relaxed control system impulse response is given. This is the meaning of this question. Okay. Now, once again, we'll discuss another question. Another question is unit impulse response of unity feedback system. Okay. This question still not it. This is related to control system, not signals and system. I'm changing the question. To produce response of t square e power minus tt u of t for a unit step input, then its transfer function is. Right now, dear friends, very clearly output is given and also input is given as unit step. Then he is asking transfer function. What is the definition? Laplace of output to the Laplace of input by assuming initial conditions are 0. Now directly values given. Laplace of output is given t square e power minus t. This is the output. Output is nothing but response. This is the output given. Input is given for a unit step. That means input to the system is step input. Unit step already explained yesterday. It is represented by u of t. Laplace of t square e power minus 2 is 2 factorial upon s plus 1 whole power 3 upon Laplace of u of t is 1 by s. The solution will be 2 into s upon s plus 1 whole cube. This will be the transfer function. Okay. Another question. Impulse response of a system e power minus 2t u of t is cascaded with another control block whose step response is 0.5 into 1 minus e power minus 2t into u of t, then transfer function of a system is. Okay. You know, dear friends, in this question, he given impulse response and another response is step response. He asked transfer function. But according to our discussion, transfer function is related only with impulse response. There is no step response. Right now, what we need to do? We need to convert the step response into impulse response. Then we can find transfer function. Because already one block is impulse. Another block is step response. Both are connected in cascade. But we don't have relation with step response directly related to transfer function. Therefore, we need to convert step response into impulse. Then we can solve the question. We know already we discussed integration of impulse response is step response. Then how to calculate impulse response from the given step response? Differentiation. Differentiation of step response will give impulse response. Now differentiation of step response value is 0.51 minus e power minus 2t into u of t. 0.5 is constant. Differentiation of 1 with respect to time is 0 and e power minus 2t is minus 2 e power minus 2t. And 0.5 into 2 will be 1 into e power minus 2t. I'm sorry, I need to change the question little bit. Impulse response is e power minus t u of t. Okay, now I'm moving. So one impulse response is e power minus 2t. Another step response is, if you converted impulse response, that will be e power minus 2t. Now transfer function is Laplace of first impulse is e power minus t and second impulse is e power minus 2t. So don't multiply directly e power minus t, e power minus 2t. Sir, as base is same, we can add. Don't use that mathematics. Already explained. The variation of e power minus t signal and e power minus 2 signal is different with respect to time. Therefore, this is the disadvantage in time domain. We can't multiply two signals in time domain, or we can't divide two signals in time domain. That is the reason why we are going Laplace. Hence, control system also explained through Laplace domain. Laplace of e power minus t is 1 by s plus 1. Laplace of e power minus 2t is 1 by s plus 2. Therefore, the overall transfer function is 1 upon s plus 1 into s plus 2. This will be the solution. I hope everybody understand the solution. So these are the discussions of various questions related to transfer function calculations in signals and systems. I hope up to now everybody understand how to calculate transfer function with respect to electrical circuits, second mathematics, third signals and systems. Any question we can kill maximum by below 30 seconds. This is the one of the strength of the my class, and we can solve any kind of question because I'm explaining all the areas, all the angles and all the corners. Okay, now I am moving to calculate transfer function related to our own subject, that is control system, that is transfer function of control system. Okay, already we know friends, there are two types of control actions we discussed in second class, second lecture of control system. Please follow second video of our lecture in the sequence. In that we discussed open loop control system first, then we have discussed closed loop control system. In open loop control system, the input is R of S, forward path gain is G of S, output of the system is C of S. Or instead of R of S, we can simply write R, gain of the system G, output is C. That means all the blocks are in S domain only, that is Laplace domain. Don't get confused. Now how to determine transfer function? Transfer function is ratio of output to the input, or else the output C he can be getting just by multiplying these two blocks. Why? Because R and G both are in cascade. Therefore C is equal to R into G, or C by R equal to G, which is called overall gain in open loop transfer function, or open loop transfer function. Sorry, overall gain of the open loop system, or else open loop transfer function. Open loop transfer function or overall gain in open loop system will be same, that is nothing but G. Or else, dear friends, already we discussed Mason's gain formula. Mason's gain formula is applicable between one input and one output, but not in between two input nodes, but not in between two output nodes. Anyhow, soon I am entering into signal flow graph. In depth we will discuss. But anyhow, in electrical circuits, while I am explaining transfer function for complicated circuits, we have used the shortcut with the help of signal flow graph, that is Mason's gain formula, given as summation k equal to 1 to n m suffix k del suffix k upon del. This formula I am going to use for this block right now, where n is number of forward path. Tell me dear friends, a forward path starts from input node, ends at the output node. There is only one forward path. Therefore, n is replaced by 1. Whenever n is equal to 1, we need to substitute only k value as 1. That is m1 del 1 upon del. How to calculate del 1 minus sum of loop gains? There is no loop in this open loop system. Sum of individual loop gains will be 0. As there is no single loop, how we can get two non-touching loops, all those things. Therefore, del is simply 1 minus 0. What is M1, dear friends? It is the path gain for first forward path. This is the first forward path. What is the gain of the forward path? G. Therefore, M1 we got. Del 1 is same as del, that is 1 minus 0, by removing touching loop gains to first forward path. Now dear friends, to this forward path, any loops are touching? No. Therefore, no loop is to remove. Therefore, del 1 is same as del. Hence, overall open loop system gain is G, or open loop transfer function is G. Either you are going for this method or by this method, result remains same. Okay. Now, how to calculate transfer function of a closed loop system? Closed loop control system. Dear friends, reference input already explained, represented by R of S, or simply R. This is error detector. Input is always positive. Error detector will give error signal. And this is the forward path gain G. Output of the system represented by C. Feedback path gain is H. And already explained why we are using negative feedback path in control system. This is a negative sign because negative feedback we are using. Dear friends, we have two methods to explain this one. Let's say this error signal is E. error E is equal to, node means sum of incoming signal speed, or error is this one. Error is sum of these two signals. One is positive signal, that is R. Another signal is negative feedback signal, that is coming from C. Therefore, multiplication of these two, that is C into H. Now, output of the signal C is equal to just multiplication of error with forward path gain, because these two blocks are in cascade, that is E into G, where C is equal to, substitute E value here, that is R into G minus C into H into G. Take this term this side, take C common, 1 plus GH is equal to R into G, that is C by R is the transfer function, is equal to G upon 1 plus GH. This is called overall gain of a closed loop control system, or else closed loop transfer function. Overall gain between input and output of the system is G upon 1 plus GH. Suppose instead of negative feedback here, if somebody use here as a positive feedback, then overall gain of a closed loop control system or closed loop transfer function is G upon 1 minus GH. This is for positive feedback and this is for negative feedback. But remember this formula more. Why? Because we are designing closed loop control system with negative feedback for more best results, but not positive feedback. For negative feedback it is 1 plus, and for positive feedback it is for 1 minus, right? This is the solution for how to determine closed loop transfer function for negative feedback, and this is for positive feedback. This is one way, and we can also use Mason's gain formula that we will check right now here. Input is R, forward path gain is G, output is C, feedback path gain is H. This we need to convert into signal flow graph. Input node is R, how to convert block diagram into signal flow graph I did not explain, but even though we will understand. Input is R and error detector is one node, it is positive, this gain is not given, which means 1. From error detector to output of the system, forward path gain is G, and from output of the system to this error detected, feedback path gain is H, but also you have to consider this sign, that is minus H. Already I have explained, in order to get clarity for output node, just connect a branch gain of unity, there is no mistake. If you are connecting a branch gain of unity, overall gain multiplied by 1 or divided by 1, result remains same. Therefore, transfer function is output upon input by assuming initial conditions are 0, that is in Laplace domain. Now, if you use Mason's gain formula, summation k equal to 1 to n m suffix k del suffix k upon del. If you see here, from input to output there is only one forward path. This is the forward path. But don't consider this is the forward path. Why? Because arrow is opposite this path. Now, number of forward paths in that is 1, n is equal to 1. That is m1 del 1 upon del. Where del is determinant, how to calculate? 1 minus sum of individual loop gains. There is only one individual loop gain. What is the gain of this? Just multiplying these two blocks, because both are in cascade. This block gain is G, this is minus H. Therefore, minus GH. This is del. Now M1 is path gain of our first forward path. What is the first forward path? This is G. To this path, we need to calculate delta 1. Delta 1 is determined from del, where del is 1 minus minus GH. And what is the definition I told? Delta 1 is same as del by removing touching loop gains to first forward path. This is the first forward path. For that, this loop gain is touching. Therefore, remove that loop gain. Hence, this value is 1 minus 0. It is G upon 1 plus GH. If you use either signal flow graph concept, that is Mason's gain formula, or if you use transfer function, that is general discussion, also result remains. I hope everybody understand. Dear friends, now overall gain in case of open loop transfer function is, open loop system is G, Closed loop transfer function or overall gain of closed loop system is G upon 1 plus GH. Suppose this is input, dear friends, this is error detector, gain of the system is G, output is C, feedback given as like this, that is for feedback path gain is given as unity, that is H is equal to 1. If feedback is gain as H is equal to 1, then closed loop transfer function can be written as G upon 1 plus G. Reason H value is 1 or unity feedback is given. Unity negative feedback. Already we know that G is nothing but open loop transfer function. Therefore, the closed loop transfer function can be written as open loop transfer function upon 1 plus open loop transfer function only when feedback is given as unity value. This is the relation between open loop transfer function and closed loop transfer function, and this formula or this shortcut is valid only when unity feedback is given. Otherwise, we can't apply this shortcut. From this, we can get open loop transfer function as closed loop transfer function upon 1 minus closed loop transfer function when feedback is unity gain. So whenever closed loop transfer function is given and feedback is unity, negative feedback value is given, how to calculate open loop transfer function? Use this shortcut. Whenever open loop transfer function is given, how to determine closed loop transfer function for unity negative feedback? Use this formula. These are the shortcuts, but these two are valid only when feedback value is given as 1. Otherwise, these two are invalid. Okay. I hope everybody understand, and tomorrow we will solve how to calculate transfer functions of various control systems. Thank you, dear friends.